Well, hello, all good people of the world. This is Paul Whittakin coming to you today with the universal law of numbers, which is a law of nature, and actually we can call it just the same, the universal law of nature, and sometimes I do. And we can call it a lot of things because we're allowed to call it whatever we want. Okay, very good. So I'm going to arrange that, hopefully, so we can all see it better. And I'm going to try and get a lot of information in this one presentation because really, in order to understand it or appreciate it on any level, you would have to kind of do a lot of this arithmetic yourself. So what I'm going to do, first of all, is just show you a big picture of it, show you how the thing works together as one big package, and remind people that this is the universal law of numbers, and the universal law of numbers is the 369 code. And what the 369 code is, anything that you ever understood in your life to be mathematics is the 369 code. But I have to point out that when we learn mathematics, we sort of overlook some very kind of essential part of it that is, it's implicit in being able to understand how this system works, because as I point out, this system goes in repeating sequences on to infinity in all directions. And the first one is this direction, because when we get to 9 and we turn the corner and it's 10, 11, 12, well, 10 is a 1, 11 is a 2, and 12 is a 3. And we have a tendency to overlook that as a curious coincidence that we don't incorporate into the entire understanding of the mathematics. But in reality, it's the basis of the thing, because the universal law of numbers is the 369 code. And I'm teaching the 369 code, and the 369 code, when we learn it, we become proficient in mathematics because it's a complete understanding of mathematics, and it's an easier way to progress to the big picture. So the big picture is, this represents nature, it represents the universe, it has all the natural sequences that occur in nature that can be described with numbers. Many numbers have a relationship with nature. You know, the Fibonacci code, we understand that's related to nature. Euler's doubling, you know, Euler's number 2487512, that's what that is right there. You know, we have numbers like phi and pi that occur in nature, and they all occur and are described with the universal law of numbers. So to get started, this is what the universal law of numbers is, if I just show it to you like that. Okay. Hopefully, we won't have that problem so much. Let's see. Okay. Okay, so that's just another way of looking at the universal law of numbers. So the universal law of numbers describes the numbers working in the entire universe, and as we see, you know, this is just squaring the numbers, taking them to the 7th power. And what happens is this sequence goes 6 in this fashion. And then it repeats again, 6 in this fashion, repeats again, 6 in this fashion. And it takes on the codes 285, 396, x to the 417, x to the 528, x to the 369, and x to the 741, because it goes 2, 8, 14, that's 2, 8, 14 is a 5, followed by another 6 is 20. So this line here would be x to the 20th, that's a 2, followed by, goes to the next sequence, it's x to the 26th. 2 and 6 is an 8, takes the next sequence, 28 plus 6 is 34. And 3 and 4 is 11, and 11 is a 2. So we see this sequence, the exponent, it follows the code 285 to infinity. And what happens is these exponents are the 369 code as well. So if we begin to understand how these exponents relate to this universal law of numbers matrix, we will be able to put the package together a lot simpler. So this is just one way to look at the universal law of numbers. And what I'm going to do is I'm going to show you just what happens. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. Well, we know that that gives us the code 149779419. And this applies to any number that's that number. Let's say there's a number, let's say 24. Well, 24 is a 6. That means that 24 times 24 is going to reduce to a 9. So anything that applies here applies to all numbers. And another thing I want to kind of show you is, well, okay, so this is the 369 code. And the 369 code, I do things like I go 4 times 8 is 32 is 5, 7 times 1 is 7, 7 times 8 is 56, 5 and 6 is 11 is 2, 4 times 7 is 28, 2 and 8 is a 1, or if I go, let's say 4 times 7 is 28 is a 1, and 8 times 1 is an 8, and 7 times 4 is 28 is a 1. Well, when I do that, what I want you to understand is that that is applying to all of the numbers that are in the sequence as they are in the sequence. And this is basically the sequence, and it gives us the 369 code. So I'll just show you, okay, so now that we sort of see all these numbers in the 369 code, we want to understand how that all applies in conventional mathematics. Well, okay, in order to do that, we understand that the 369 code, the universal law of numbers code, is this. Okay, so this is what it is on the first time around, going from x squared to x to the 7th, and we see these group of numbers. Now, if we understand how these group of numbers work together, which are the universal numbers, they come from multiplying the numbers by themselves over and over and over, they present us with a pattern. And the pattern that takes place inside of here, the same patterns take place along with the exponents. So we're going to kind of get to that, but what I'm going to do is I'm going to say, okay, you might look at this as some sort of an expansion of what we learned in school as the multiplication table. Okay, so if you want to look at it like that, now we have a larger multiplication table, and these are the common familiar numbers, and they will reappear over and over and over and over. And if you can understand just how these fit together, you will understand that this is like a stairway to heaven, and this is just the first step. This is step number 1, but every step is going to be built in exactly the same way from the exact same prototype, which is just the 369 code, because x to the 2nd, 3rd, 4th, 5th, 6th, 7th, it repeats again 8, 9, 10, 11, 12, 13, 14, 15, 16, it repeats in that fashion. It repeats in this direction. If we put a minus sign in front of the numbers 1 through 9, it repeats in that direction. And if we take the square root and cube root and the 4th root, 5th, 6th, 7th root of these numbers, they will repeat in the same fashion, and the numbers will never change. So, what I'm just going to show you is how these numbers, they turn into more familiar numbers that we can all work with. And we all learn this basic mathematics. What we will do in turn, this basic arithmetic, it turns into what people in the conventional world call, well, algebra. If you want to look at this in terms of exponents, well, those are logarithms. So when we do algebra, we're reducing numbers, and we're showing them written in different ways, and that's all I'm doing here. But it's a repeating sequence, because now we're on the second line going across. 1, 16, 81, 256, 625, 1296, 24, 1, 40, 96, 65, 61. Well, that's a repeating sequence too, because it's the 179449719, and we can understand it in terms of numbers, familiar numbers, whether they're written out or if they're shown with these abbreviations. So these abbreviations are just the simple abbreviations, and if you don't know what they are, they're not at all difficult to understand. Okay, what times what is 256? Well, 16 times 16 is 256. And 16 is also 4 squared. And it's also 2 squared squared. And it's also 2 to the 8th inside of one of those, which would make it 2 to the 4th. And it's also 2 to the 12th to the 2 to the 12th to the 1/3, because 12 over 3 is 4. So we learn how when the exponent is inside the bracket like that, and we take it to the power, that's when we multiply the numbers together. So 4 squared squared is going to be 4 to the 4th. If that was 4 to the 2 times 4 to the 4, then it would be 2 plus 4. But when we put them together like this, that's 2 times 2, and that's how we learn how exponents work. And you will be amazed that if you were to learn how to do this, you would, in short time, first of all, you don't need a teacher. Second of all, you don't need a textbook. And third of all, you really don't even need a calculator per se. Now, I'm not going to say that I never use the calculator. I absolutely do. But as I do this arithmetic, I become more and more and more and more and more and more familiar with the actual numbers, because they repeat over and over and over and over again. And they're just the same numbers being expressed with a different notation half the time. Okay, so another thing is you are going to learn the numbers like this. Even if you don't know these numbers, you will begin to see that these are 8 numbers, these are 3 numbers, these are 5 numbers, 6, 7, 8, 9 numbers. They all have their own identities, and that's what happens. So all of these numbers, just doing it like that, going through the 369 code, I'm going to show them to you, but it's just to give you an idea what I'm doing. I'm showing you how, if you're becoming familiar with these numbers doing conventional mathematics, well, if you became familiar with these numbers utilizing the 369 code, you would absolutely recognize all of these numbers when you're doing mathematics, because they're the most common numbers, and they're following the 369 code, because mathematics follows the 369 code. And if you kind of delve into this a little bit deeper, you will begin to understand that entire field of mathematics much more, in a much more understandable way, because you will basically figure out that the entirety of the whole thing is nothing more than arithmetic with numbers, and it's all dictated by the 369 code. So that's what that does. Now, we'll just go to the second. Now we're on the second page. Now you see that these numbers, they're starting to get to be very large. But if we look at them in terms of this, and we start to learn how we break them down, for instance, 6 to the 9th. Okay, so we can figure out a lot of things about 6 to the 9th. If we look at the universal law of numbers, and we're at the 9th, the 9th level, exponent 9. We know that all of those numbers are going to be perfect cubes. We know that all of those numbers are going to, for instance, we know that if it's the 3rd power, it will be a perfect cube. If it gets to the 6th power, it will be a perfect cube and a perfect square, because both 2 and 3 can be divided, 6 can be divided by both 2 and 3. So we know that all of these numbers that fill these boxes, they are going to be perfect squares, and they're going to be perfect cubes at the same time. So when you start doing calculations with these numbers, you will begin to see how the whole thing fits together. Like I say, you know, if I'm doing one of these things, like 1 times 2, or 2 times 4 is 8, or 1 times 1 is 1, or 5 times 7 is 8, that applies to all of these numbers here as well. It's just you have to see where the number falls into its block. I don't know if I got that across very well, but now we'll just go, and I'll do it quickly, and we're at 1 to the 10th, and now these numbers are getting really big. You know, it's like 8,589,000,000, etc., etc., etc. But it's still just, if we break it down like that, we see that it's following the pattern, 8 to the 5th times 8 to the 6th, which are these numbers, which are the familiar numbers right off of the first page of the universal law of numbers. So if we get up into the 12th and the 12th power, etc. Okay, so now the calculator isn't even working anymore. If I want to know what 7 to the 12th is on my calculator, it's not going to do that, because it's going to give it to me with to some power to the 10th, which loses the entire sequence of the 369 code. It's not valid because it's not accurate. It's just an approximation. But now we can take our knowledge of the 369 code and we can keep on going and going and going and going, because we don't need a calculator, because we have the calculator that is the mother of all calculators. And it's the 369 code, and the whole thing expands out to infinity. So we went to the 13th power, that's enough, but I'll just quickly show you what it breaks down to. It just breaks down to these very familiar numbers, and they're following the very familiar code that we're given by the universal law of numbers, and we're going to just show you them. So all of these numbers, I mean, I don't know what anybody's particular level is of arithmetic or mathematics, but now I can tell you I know what all of these numbers are, and I don't even need a calculator. And I'm calculating numbers that are going out into the expanse of infinity. And it's not about memorizing the numbers or anything like that. It's just we recognize the pattern, and the underlying pattern is just, once again, 149779419. What was that? That would be out of order if it is. Okay, 149779, 189189, 179449, 159729489, followed by 119119119, and finishing off with 129459789. That is all it is. So now we'll just look at these exponents again and see what we get. Okay. So what we're going to do today is we're going to do a little exercise. I'll throw that one there. Okay. So we're going to remember that the exponents go like this. That's how the exponents go with the universal law of numbers. It goes 2 through 7, then 8 through 13, 14 through 19, 20 through 25, etc., etc., etc. And if we were to look at them, well, we're going to look at that in a second. All that does is it breaks down to this order. It's just 2, 8, 5, 3, 9, 6, 4, 1, 7, 5, 2, 8, 6, 3, 9, 7, 4, 1. And that just keeps on going over and over and over and over to infinity. And what we can do with them is we can do just a little maneuver, a little mathematic manipulation with these numbers, and I'm going to do that today, and I'm going to show you what that actually means. Okay. So we have this universal law of numbers. And basically, if we do this one little thing, and what we're going to do is we're going to take, if I find it, should have it here, right here, no. Let me see if I have it. Probably put it in front of that. Okay, we can look at it from this one. Okay, so this is the universal law of numbers, looking at it this way. And we're going to do this little manipulation with the number. What we're going to do is we're going to take the exponent, the number that's up here, we're going to put it down here, and then we're going to minus 1 off of that number. And there's a reason why we're doing that. And the reason why we're doing that today is because I'm showing people in the world that if we do that with the universal law of numbers, what kind of result will we attain in doing such? But it's generally understood it's a way of measuring a rate of change between things with respect to different things, such as distance and, a rate of change, instantaneous rate of change, the rate of change at one particular moment with respect to things like distance and time. So we're going to do it, and here I've done it, and there it is right with the first page. So I've done it with this page right there, and we're going to call that d over dx, and I'm going to show you what happens when we do that. Well, basically, you do that, and then you'd have to do the arithmetic, and then you do the arithmetic out, and then you reduce the numbers, and you get something that looks like that. Okay, and then if we do it with the second page of the universal law of numbers, and then we reduce it, we're going to get something that looks like that. Now, we're not going to go over each one of these things, but as you're all aware, what we always get is the 369 code. In this case, I can see the codes 852, I can see the code 741, and I can see, for instance, there's a code 189, 189, 189, but in any event, it's always going to be the 369 code, okay? And if you want to look at it individually, you can do that by just slowing down the video. But as you can see, I've gone through the whole thing, and I get the matrix that results in doing it like that. And here we're up to the 4th page. So we're getting into very large numbers here. I mean, I don't know what 9 to the 25th is, per se, but I know it's following the 369 code. And I can know a lot about it just by simply understanding that it is following the 369 code. And we're just going to go up in numbers and numbers, higher and higher and higher. And now we're up to the 5th page, and that's what we get. And this is the 6th. And we get that. And then I'll just go a couple more. So that's 6, 7. All we've done is we do this little maneuver by taking the number that it's up there, minusing 1 from it, and bringing it down there. And then we're going to reduce them, and we're going to see what it gives us. And in each case, it's going to give us a 369 code. Okay, so let's see what it gives us. Now I've basically reduce them so we can see them like that, and that's what they reduce to. And what that reduces to is the 369 code. So if we do this ddx with the universal law of numbers 369 code, we come up with the code 369, 369, 369, 999, 639. I think you will agree that that is the 369 code. Okay, so that's basically what I wanted to cover there. Now we're going to talk about perfect squares. So perfect squares, no matter how many pages we do, just like I showed you, page after page after page after page, just like the universal law of numbers will have a its sequence, which we're all familiar with now. We know what the universal law of numbers looks like. This is what the universal law of numbers looks like in terms of the perfect squares. So these are the numbers that are the perfect squares. And what they're doing is they're giving us the blueprint, the foundation. It's telling us how the system works. Okay, so there's the perfect squares, and those are the numbers themselves. And we will notice right away that the perfect squares are going to have the exponents with the even numbers, 2, 4, 6. Okay, but ones are always going to be perfect squares. They're perfect everything. It's 1 to the 34th power is still a 1. And nines are always going to be, give us nines, reduced to nines. And they're always going to be perfect squares as well. Okay, we'll also notice here that the 4s give us perfect squares, and we should take note that this is 149, and we should know what 149 is. It's the first sequence of numbers in the universal law of numbers. So here's another way of looking at them, and here we're beginning to see them. Okay, so now these are those familiar numbers all over again. It's just the same exact numbers. So we become familiar with these numbers. I know that 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 3125, times 5 is 15625, times 5 is 78125, etc., etc., etc. And I know if I were to expand this into infinity, I could just start putting the exponents on those numbers, and I could get out really far, but it would still be perfectly contained, because all I'm doing is I am expanding the universal law of numbers with the perfect squares. And here we look at the perfect squares like that. And here we can look at numbers that are both perfect squares and perfect cubes. But I think that's ahead of the thing. So here I'm going to do that same operation. I'm going to measure the instantaneous rate of change at that particular moment with respect to the universal law of numbers. And I'm going to do it with the perfect squares. And we are going to see that that is going to reduce to something that looks like that. And I think that if we were to look at that, we would also recognize that as the 369 code. Okay, so the way the 369 code works is if we measure the 369 code by multiplying it against itself, codes against codes, we will always receive codes.